So welcome to Building a Secure Agile Hybrid Cloud Network. My name is Jim French. I've been with Cisco since starting a different millennium, 1997. And in my early days, I did a lot of DMZ designs. And I've ended up having to go back and do those because they're very customized, very secure environments for many years, even though I've done other stuff like ACI and data center. So now as customers were adopting cloud, a lot of that came to the forefront because clouds are semi-trusted connections from basically a partner that is providing hosting for all of you. So before we get started with this, and we just announced this offer, it's at its early phases. It was called yesterday Secure Agile Exchange. When I created this session, the name didn't exist. So I put in AKA Exchange, so if you see any other marketing collateral this week, Secure Agile Exchange is it. So before I get started, I just wanted to get a sense of where all you were coming from, because this could be a very broad audience, and I wanted to understand where you guys were. So first off, get ready to raise your hand a lot. Who is a service provider here? How many do we have? So mostly not service providers. And in service providers, we would want to partner with you to offer this to your customers once we get through with what it is. How many are, let's say, using cloud for app development? And then production? So even more. So some just dabbling, and then probably maybe a quarter, I think, we're using it for production. And then let's get a sense of who's using which clouds. So AWS? Maybe a quarter. Azure, and that's even more. So Azure, not Office 365. Okay, so like just as infrastructure as a service. So similar to Amazon. And then how many people are virtualizing firewalls, load balancers, IPSs, and routers in their current private infrastructure? So even more, maybe a third, so that's good. So I have some more questions, but I don't want to make you guys do that for 2 hours. I have lots more questions. But so let's get started, and I'll ask questions as we go through. So what we're going to do is just talk about where customers are in adopting cloud, our customers being you. And we're going to look at the changing network requirements, because as you start to adopt cloud, what's happening is applications and data are leaving your data center, right? And the word center is no longer the center of the universe. The data center is just a place where I host applications and data. And I may host those applications and data in many other places. I didn't ask you if you had deployed SaaS, because I almost assumed that 100% had tried some kind of SaaS. So you've already got a lot of apps and data leaking out of your data center. And it's like, what should the network look like in light of these dramatic changes in where all the consumers of applications are going to? So we look at the application interaction requirements from like a basic level, like a do-over kind of perspective, and then go to organize these application interactions so that we can build infrastructure that is organized, repeatable, and then orchestratable and automatable. You get all those words, right? So the reason we had a lot of trouble over the years, in my view, in orchestrating and automating networks, it's partly because we've been building them somewhat ad hoc, right? So if we're going to change the way we build these things, let's do it in an organized fashion so that we can orchestrate and automate and virtualize in the process. So then I'll introduce you to the concept of Secure Agile Exchange and what a point of presence looks like, where it might reside, and the technologies that go inside. And then we'll look at the technologies deeper, as far as virtualization and then orchestration and automation of these external connections. All right? And then a perspective of what IT as a service will look like. So cloud adoption, I'd drawn this a while ago. You've got consumers of applications. Usually it's employees, partners, customers. Those are all consumers. Sometimes it's machines. And they have to consume applications, and the applications present data. So what we've been building for my entire time at Cisco, which is a long time, is networks that will take all these employees, partners, customers, and bring them into our data center, because that's where all of our applications and data have resided. And and over the last 5 years, maybe we started consuming some SaaS, so that's sitting out there. So and we'll backhaul all the SaaS-bound traffic through our private data centers out to the internet. That's a very common model. So what I had is customers coming to me, and typically a few years ago, if you came to Cisco and said, you know, I'm going to use cloud, we would tell you you didn't want to use cloud. So what I'm saying is this is the approach to help you do what you want to do if what you want to do is go to cloud, right? So I've had customers say, we're going to be cloud first. And then I had a customer that said, not only are we cloud first, we don't want to be in a data center business. So we're going to close out our data centers and, you know, refactor, lift and shift all our applications to the cloud. So I'm like, how do I differentiate, you know, those two customers? And usually there are many. So on the cloud first, what it means is really when you have a new application requirement or an application replacement requirement, you're going to go through a decision process that is probably public SaaS, public IaaS, private data center, commercial off the shelf, and, you know, private data center custom. I mean, that would be your decision process. So that's cloud first, and then you say, how long will it take me to actually have all my applications in the cloud in that approach? Well, that approach would take you the life cycle of an application to cycle through all the applications that they end up in the cloud, and that could be, you know, 10 years in some industries, but in insurance, where I have some customers, the life cycle of an application is a lifetime of a human person because they create an application for an offer, and they can't, you know, discontinue that application until all the people have passed on. So it's literally a human lifetime. So, you know, it could be a long time. So that's the cloud first is a long journey, and then the cloud all in means I'm going to take and spend a lot of money on just getting out of the data center business and putting all my applications in the cloud. And I haven't seen a project from a customer that is more aggressive than about 5 years to do that. And usually they're late. But if, like I had this one bank that's like, you know, their company, you know, technology 2020, and their goal was this. And they actually think in their head they'll terminate all their network connections into the public IaaS data center, and then split out the traffic, go through some content filtering out to the internet, and then drop off private applications into like virtual private clouds, like in an Amazon, right? So whether they get there or not, it's going to take more than 5 years. So, and also they will be multi-cloud, so it gets a lot more complicated, and we'll look at that later on. So what they would be, whether you're cloud first or you're cloud all in, you would likely end up in a place like this. So this will be the bulk of the hybrid cloud customers, and likely terminate in a carrier neutral facility. Why? Because I've got potentially a third of my applications in my private data center, so my private data center becomes a cul-de-sac. It's got an equal number of applications and data as I do in public cloud and potentially my SaaS clouds. So you have essentially a hub sort of topology in a colo, and there's some other awesome, you know, capabilities there, because in that colo, I usually have cheaper access to WAN bandwidth, or very available access to WAN bandwidth. I have very available and usually cheap access to internet bandwidth. I have direct connect and express routes into the public clouds, so, you know, high performance connections into the public cloud facilities, and usually I can get pretty decent priced bandwidth back into my private data center. And we'll look at some larger topologies of that later on with multiple clouds, but, you know, this is the concept. And for some of you who may work for larger companies, what I've come across for conglomerates and other big companies is that they may have one business unit that is private first because of regulatory, you know, compliance kind of reasons, another business unit that is a cloud first, and another one is cloud all in. So even in that environment where you have different groups within your companies with different requirements, you end up in this sort of hybrid cloud topology for a really long time, right? So what are we doing? Essentially, if you fall into the private cloud first category, then, you know, we're virtualizing, orchestrating, and automating your DMZ, right? And you may just be doing app dev in the cloud, So in which case you'll do VPN connections into the cloud to do application development, but you don't need a direct connect. You don't need to live in a colo. There are some reasons still to live in a colo, and I'll share one now, which is I have one customer that their partner extranet has 1,000, and you saw partners on the last slide, 1,000 connections. And just by taking those 1,000 connections and putting them in the colo, they're saving about 25% or $250 per connection, which equates to $250,000 US dollars every month. So it's significant savings. And really all it is take the connections for my partners out of my data center, move them into a colo, and then backhaul them into my DMZ, which still resides in my private data center. So that's still an option in this topology, right? So, and we'll talk about this, red part, which is the virtualize, orchestrate, and automate the DMZ, and bringing patterns to our DMZs so that we can do that. And then, of course, if you do have a lot of SaaS or a significant amount of SaaS, you can still do direct internet access, which we offer with IWAN, so I can split my traffic out into branch and go directly to the SaaS providers without going through the private data center. Now, this is the other topology, which is the bulk of the hybrid cloud customers for the foreseeable future. So I'm bringing in my partners, my employees, my customers into the colo, again, virtualizing, orchestrating, and automating all the external connections, and we'll look at the details of that. And from there, I've got my public clouds, many public clouds. I don't draw the lines for the direct internet access because there's a fine line. Do I need to do direct internet access for my SaaS applications? If I'm dropping off my WAN in a colo and the clouds are in a colo, couldn't I just leave the direct internet access traffic inside of the VPN tunnel, terminate it in the colo, and then drop into the clouds if the goal is direct access to the public SaaS and public IaaS clouds. And then lastly, if I ever get to this place, and there's a lot of reasons why you may not ever get to this place, which I'll share later on, but if you were single cloud and you get to this place where you're going to terminate your network connections in a public cloud and all your application hosting is in this public cloud, then guess what? We've built a virtualized, orchestrated, automated, essentially transit VPC. We're building it in a colo because you're multi-cloud, right? At the front door of all the clouds. But if you are one cloud, you can put this virtualized, orchestrated, automated DMZ in the cloud. Does that make sense? So anybody have any questions on the different approaches? Right? And feel free to ask questions anytime. It's because I have you for 2 hours, and that's a long time. And I appreciate you guys sticking it around for that long. So let's look at all the different interaction types and how we're going to build an infrastructure that handles them, and how we're going to organize interaction types for repeatable patterns when we build networks. So this is something I built about a decade ago. I've done VDI, all kinds of different things, and I tried to lay out some way of organizing interactions within a company. And so you have, if you know ACI terminology, there's application consumer, application provider. You can think of it as client server, however you'd like to think of it, but I try to consistently use consumer and provider. So what we've worked on for 20 years is an employee on a PC in a campus, crossing a private network, accessing an application that presents data. So really it's a user on a device in a place, crossing a network, accessing an application that presents data, and this is all private, right? And this has been a journey, right? Just to do this. And we've also worked on, and this is all trusted, so the further we go down the rows of this table, the less trusted the things become, whether they're places, things, people, whatever. And so increasingly, even the users are becoming more distributed, not just our applications and data. We have more users, like in a cafe, crossing the internet over an SSL VPN or just SSL applications and going into Salesforce.com, right? So how do we offer a a good experience, and how do we secure and audit our users that are in cafes accessing SaaS applications, right? And then lastly, we can't forget about our partners and our B2B, B2C connections. So they come off of, usually it's machine to machine, so they're coming in from a third-party connection, usually over an IP VPN, or at least that's the usually the largest form of a partner connection. But we still have MPLS and lease line partner connections. And today they're accessing applications in the private data center. But as we adopt public cloud, we're going to have partners that need to access applications in our public IaaS clouds, right? So there's a lot of different permutations. And really, I could highlight any cell in any column, and that would be a interaction type. And I tell my son, who's in college, for ComSci, yay him, it's just as good to know what you don't want to do as it is to know what you do want to do. So I give him a lot of dirty jobs, so he knows what he doesn't want to do. But in this case, Xing out certain interaction types or methods or places is a perfectly good approach, because knowing what you don't want to support is important too. So we good there? And you can modify that table to match your environment. These are generic perspectives, but the approach is the same. So now we know the interaction types we have to support, which are not necessarily the interaction types that we had 10 years ago, right? So I'm an L4 through 7 services guy at heart. I mean, I did routing and switching, but I've done a lot of firewalls, load balancers, monitors, and that kind of thing, WAN accelerators. So I look at the world as, there's a network, and then there's a whole bunch of things that we have to insert into the path of the traffic between the consumer and the provider or the client server. So this is how I try to organize the service chains that we have in our infrastructure. And this will be the basis for how we sort of orchestrate and automate later. So you have a consumer access chain and a provider access chain, or a provider chain. So a consumer access chain may start in a branch, and you go through a set of services in the branch before you leave the branch. And I call that the consumer access chain. And then that has to terminate somewhere. It could terminate in your private data center, which is likely today. And if it does, you may go through service ABC in your branch, and you're going to terminate and go through CBA on the other side. Because if you're going through a firewall, a WAN accelerator, monitor, router, you're actually going to go through the opposite order. So guess what? That's a pattern. That's an opportunity for orchestration and automation, right? Especially in a virtualized world where I just have a host there and I can create any service chain I want, right? And then that's my new logo for Secure Agile Exchange. I'm just making stuff up, stole it from Google, right? But then you come into the data center, and whether it's in an Amazon VPC data center or it's in your private data center, there's usually a set of north-south access services. So you'll have a firewall load balancer, ELB, ALB in the case of Amazon, and then you hit your application servers. And between the application servers, you have instance-based security. If you're a VPC in Amazon or in your own data center, you could have like firewalls for a PCI-compliant environment. But so what Secure Agile Exchange is not, again, knowing what you don't want to do is important. What it is not is user access control in the branches, and doing authentication and putting a user into a segment inside of a branch. And it is not microsegmentation in the server farm. What it is group-based policy and coarse-grained control of communications between those regions, right? And we'll build up for that. So it's focused, the dashed lines, that's what we're focused on. Not inside the server farm, not inside, the branch or even the partner. So if we start organizing all the things that we've talked about, and if I haven't, and I haven't because I remember not saying it, is green is trusted, yellow semi-trusted, red untrusted, and you can make arguments and things, but I'm just creating generalizations. You create your own trust standards when you go through the process. But we basically have employees on the WAN, we have employees on remote access VPN, we have partners on remote access VPN, then we have customers and partners on dedicated private line circuits, IPVPN, whatever they are. And then I have customers and partners that use public applications, publicly facing applications, maybe through just identity and authentication. Those are all the primary consumers on the left side. The right side are my providers now, which are growing in number. So I have my private data center. I've got my primary clouds. So I've got AWS and Azure here. It took me a really long time to learn how to say Azure, not Azure, the color. So Azure. And then ServiceNow, a lot of customers are using that as an IT service catalog, IT service management. And that's actually a partner connection. It is a dedicated link to them. And I've worked with Cisco actually on adopting ServiceNow. And then you've got the public internet, which is comprised of SaaS applications, right? And as you see Cloud Lock there, because we'll get into like, how do I want to treat different application types. So if I want to organize my security policies in this environment, what's the best way to do it? Well, going all the way back to like our LDAP, OU kind of stuff, is I want to do it at company level. I want company level security policies, essentially organizational units between me, my company, and all the other companies that I connect to, and that is the coarse grain way to organize my security policies. So breaking up organizational units, we have ours, so like my own organizational unit. We've got business partner organizational units, whether somewhere I have a contract, I'm exchanging money, they're either my customer or they're providing a service to me. And then so clouds fall into that. AWS, Azure, they are a business partner. You pay them and they provide a hosting service for you, just like other partners that you may have. And then the unmanaged organizational units. You can have managed organizational units on your public internet. That would be people, even individuals, that have a profile. But an individual that doesn't have a profile is unmanaged. Going out to the internet, you've got SaaS applications, again, business relationship, managed, and you might use Cloud Lock for those. And then you have all the rest of the internet, not a business relationship, unmanaged. So it gets into, is it a managed organizational unit or an unmanaged organizational unit, or owned, right? So that's kind of the big picture. Again, not doing the edge, micro-segmentation of users and apps in the hosting environment. So if I take those groups, and your groups may be different. If I work with a retailer, the retailer in their store, they have customers in the stores, they have PCI environments, maybe another group. So you might add that. So you may have in your business other groups that I don't define here. But you can use the process. And so this is a mapping of all those groups. And in this case, green means can talk. That's usually pretty easy. Red means cannot talk. That's usually pretty easy. Yellow, which is the most color you see here, is the hard part. So yellow means I'm going to limit access control, usually access lists, deep-packet inspection, auditing, logging, those sorts of things, because they're semi-trusted, right? So it's easy to do the untrusted, just don't let them in at all. It's easy to do the trusted, let everything, but these yellow zones are the hard part. And of course, black would never happen, because unless you're a transit for the internet, you would never see that traffic, right? So any questions here, and feel free to chime in. You guys are making me nervous not saying anything. So if we look at this, usually those yellow blocks, you're already doing them today somehow, right? You've already built those yellow blocks. They're usually static, fixed, physical service chains of stuff, lots of stuff, big piles of stuff. So this is just like an engagement of what the service chains may look like. And it'll vary. You know what yours are. Actually, you may not know what yours are, but you could go figure out what yours are. So you have your WAN, and you may come into this hub, and we'll get into the details more on it. And you may just hit a router and some WAN accelerators. I try to be generic because we're supporting any vendor, right? So I'm using Gartner terms sometimes, like WOC. That's a WAN optimization concentrator. For us, it would be WAS, but you may know Riverbed, whatever. And you got your remote access VPN to B2B, B2C, so those are usually like a firewall or router firewall. If it's all on the internet, there'll be a shared hardware router on the outside. So those are your consumer service chains. The public, like the e-commerce applications typically have a firewall, a load balancer, a web application firewall, a load balancer, the web tier, and a firewall. And when I write these down, I look at it and I go, the application is 1/6 of the infrastructure. And it's like, how'd that happen? So yeah, like we're deploying 6 things in that service chain, and the web tier is the only application component. And then typically the app tier, database tier are back, deep inside somewhere else, right? Often. So that's that side, and then you go into the private data center, you'll have firewall, load balancer, and in a variety of use cases, entering the server farm area. For AWS, these are just service chains I've come across with customers, so I throw them up there. It was interesting to see that the service chain for AWS is commonly longer than Azure, and I think it's because Office 365 is usually the Azure use case, and it's like email versus Amazon getting business applications. So that's at least what I'm chalking it up to. And then ServiceNow is just a typical kind of VPN connection. And then lastly, out to the internet. So internet egress is typically a load balancer, a forward proxy cache, some kind of SSL inspection, perhaps data leakage protection on top of that, and then firewall and out. So these are all your essentially service chains that you're living with today. Well, let's take them, pull them into a hub, put a switching fabric that is VXLAN based, put a whole big pool of compute resources. In this case, that's a cloud services platform, CSP 2100, and the product manager, Gunnar Anderson's right here. So if you have any sort of roadmap questions when we get to that, you can ask him. And then that other icon in the middle there is our NSO TailF product, so that's Network Service Orchestrator. How many people have heard of the TailF NSO so far? So you will later then. So that's about half. And then on top of that, it's like, okay, we got to get the network to be offered out of a service catalog. So how do we get network connectivity? And by connectivity, I define that as network security and telemetry. Right? Connectivity is a superset of those 3 things. Is how do we get network connectivity to be offered out of a service catalog? So let's go through some examples. So a full service chain, like we talked about before, is a consumer access chain and a provider access chain. So this would be an employee, coming across the WAN into this facility and then out the internet egress and all those services. This would be like a typical 3-tier application, except the web is hosted inside of Amazon, and then you still have app and database logic in your data center, and then that app server may go out and get a stock quote or inventory or something from the internet. So that would go through this hub multiple times for that interaction. And then lastly, a partner coming in to the hub to access an application that you're permitting them to access in your data center is a common use case. But then increasingly, I would have to add an arrow up to, that application is going to be hosted in AWS, so I have to permit that partner into, AWS and restrict their access to that. So when you go through this becomes a really great place to do telemetry and analytics, because every interaction between any consumer and provider is traversing, this hub, right? So whether it's Stealth Watch for security, or tetration analytics, or whatever the case is, whether it's a packet-based capture and instrumentation, or it's a NetFlow-based instrumentation, I'm going to see everything. I won't see phone calls inside of a branch, and I won't see application interactions inside of an Amazon virtual private cloud or inside my ACI private data center, but I'll see all other interactions through here. So that's kind of the high level of what we're building. So the network topology at a larger scale becomes, well, you really have two choices. It's a hub and spoke, or it's a full mesh, right? And within the United States, we have the Postal Service. It's been around forever. The architecture of the Postal Service is every state within the United States has a postal hub, and we would have mail routes between that hub for that state and every other state. So 40 some odd other routes, state to state. So full mesh. And if you wanted to do security on packages, which are kind of like packets, you would have to do security everywhere because you have no other place to do security other than at the edges, unless you wanted to put somebody in the truck and do something. But so FedEx came along and they were able to deliver packages overnight, but their model was send all packages to Memphis, Tennessee. And it was funny because I just presented this to them. I was like, oh, I've been using your story. So you send all packages to Memphis, Tennessee, and then from Memphis, Tennessee, you go to the destination. So everything is one hop from Memphis, and everything is one hop to Memphis, right? So both ways. So this hub becomes like Memphis in that analogy. And so what we're building is taking those topologies we just looked at and saying, all right, my private WAN is up there, and I could be 10, 100, or 1,000 sites, that little green dot. I know I'm summarizing a lot up there. For those that work on the WAN, it's just a dot. But then you have your partner connections, which are often even larger than a number of branches, and then the internet customers, and down here your providers being your private data centers and things like that. So I worked with some financials, and they're like, well, this isn't going to work because I need to do replication between these data centers. I'm like, well, if you need back-end storage replication, you can still run those connections, but from an access perspective, your data center can be a cul-de-sac off of these hubs, and you can still do storage replication connections. So here you have the hub, and we'll get into the technology, and then all those hubs become high-speed connected across a core, and you may have n number of these. A global company will have 6 to 8. A national company would have 2, multinational somewhere in between. So that's typically the topology you'd end up with. Again, if you have distributed applications across clouds and everything. And notice I have 3 public clouds. That's often a very common number. Now, once I have this topology, it's like, well, everybody's going through Memphis. What else should I put in Memphis, right? Like, well, a lot of security, we know that. We're doing all our package inspections. But what other shared services? Because if I have customers that are like, well, we have Oracle databases. Those Oracle databases will be consumed by all the clouds because there's application components in all the clouds. And those clouds don't support bare metal. Some do. But so let me put my Oracle databases on bare metal infrastructure in this hub in a colo. Others are like Active Directory, DNS. Actually, there's a slide for that. I don't have to remember them all. I can put them up on a slide. So you can see all the different services. Then wait a minute. I also have access to a lot of TDM circuits inside of a colo. So my voice gateways, call control, all kinds of stuff can reside here to provide services to both the clouds and your branches and your partners. Message buses, API gateways, anything that's going to be used by all clouds and your data center would make sense to put in this hub. We're good? So the alternative, the US Postal Service alternative, and yes, I didn't get enough sleep one day, so I just drew this. So you have the same diagram, and you're like, well, how would I do this in the US Postal Service model, which is really a VPN model everywhere to everywhere? So before I do that, so you have your private WAN, and with IWAN I'm missing lines. Even with all these lines up here, I'm still missing a lot of lines. So I'm just doing some of them. But you have your WAN, and you can go to the internet directly from your private WAN. I don't even have the lines. So if you wanted to terminate your branches into the public clouds here, we now have a VPC, a transit VPC offer that you can terminate your branches directly into a CSR, IWAN-ish, right into Amazon, and then from that transit VPC that the CSR offers, you can hub into up to 1,000 VPCs, right, without having to create all the networks within Amazon. So that's a cool new offer. But that aside, I can notice that the WAN is green because that's my places, my OU, and these are yellow because that's somebody else's organizational unit or company. So am I okay with directly connecting all my branches, which then connect back to my data center, to a semi-trusted public cloud that is multi-tenant and shared, right? That's up for you guys to decide. If I am, then I terminate those branch connections directly into the public, cloud. But then what becomes even harder, even if that's okay, is what do I do with my partner connections as I put my applications into that public cloud? I don't control security. I do control security in my branch. I don't control security in my partner, B2C, B2B. So now I'm going to take that partner and I'm going to terminate them in the public cloud. So I got a yellow to a yellow. Where do I implement my security for partners accessing applications in the public cloud without an intermediate place? So I have to put all the security either, can't do it in a partner, so I have to do all the security in a public cloud. So when I go to add a new partner, what questions do I need to ask? Well, I got to say, what applications is this partner going to access? Where are those applications? Because they could be private data center, could be Amazon, could be Azure, could be wherever. So, and then I need to put the right, the VPN connection to where their applications are, and then put the security policies at those places where their applications are, because I can't put them where the partner is. Does that all make sense? I don't know if I'm going too fast. So that becomes difficult. So the hub is easier to manage and maintain and provide telemetry, instrumentation, access controls, logging, auditing, and all that. But recognizing that we sometimes have to do things at the edge, whether it's scale or because we have security requirements. Like I have a retailer, I've got customers, employees, and PCI in a branch. So I need to implement segmentation and security in the store, and then carry that through the hub into the various data centers. So this is the hybrid model. Some security at the edge, but try to do as much as you can in the middle. So as I was putting this together, and we have this hub, and we have a Amazon sitting off the hub, we've got Azure sitting off the hub, IBM Software, Google, whoever, right, off of this hub. What I went back to was, hey, wait, isn't this kind of like what I was doing with ACI? ACI, or whatever fabric you have in your data center, and the value of ACI is I'm going to consistently manage security and telemetry across multiple virtualization domains and bare metal domains, right? I mean, that is the goal of ACI, is I have endpoint groups and I can manage security. If I'm not just VMware or I'm doing NSX, if I had just VMware, ACI is not as valuable. If I had just OpenStack, ACI is not as valuable. But if I have multiple domains, that's where ACI really provides a lot of value. So if I deploy an application across multiple domains, doing security without ACI across 3 different virtualization domains is harder. So same thing with this. If you take this hub and you go, well, I'm going to have interactions and application components distributed across multiple clouds. They're always interacting with each other. This hub then becomes, and this is the joke, intercloud fabric, because if any of you guys have heard of that product, the thing is, that's what we're providing, is it's an intercloud fabric also, because you have to remember we have interactions between applications that are in multiple public clouds, right? And ultimately, we need to provide security between those two. So where's the value? And we'll get into the what and how now. So first, the trends. The application consumers, the applications and the data are becoming more distributed into less trusted places, right? Companies are becoming more externally connected as a result. whether it's internet, SaaS out on the internet and public IaaS. And then so, we need to do things differently with all these increasing external connections. So here the value is we have one solution, whether you're private first, hybrid, or eventually public, because we've got the transit offers inside the cloud. It's the opportunity, it's like a do-over. Don't you love when you get a do-over, right? So this is like the networking do-over. So it's the opportunity to organize, virtualize, orchestrate, automate networks, right? So when we start building this stuff out, it's like, let's do it so that we can offer networking out of the service catalog, and we'll go through that. So in the meantime, because we're going to virtualize, orchestrate, and automate, guess what? We become faster. We're agile. We're not the bottleneck anymore, and we'll see why. So improve infrastructure agility, reduce risk, again with accuracy, and improve user experience for us, for our networks. And at the same time, because we may be hosted out of a colo, or even just using it as like a circuit on a stick, where the example I gave earlier, is we have the opportunity to reduce costs, maybe even pay for this, right? So it's a cost out. Cheaper circuits and fewer man hours on things we don't want to spend man hours on anyway, right? So are you guys believing me yet? Is this too good to be true? Is this like, right? I know, I'm excited. So here's some definitions. One is I've learned in virtualizing physical network appliances. That's what we've been buying as network, IT people for a long time. Application teams stopped doing that 15 years ago, it took like 4 or 15 years it took them to stop doing that. So we're just at the cusp of that. And I asked you earlier how many people have virtualized. Probably isn't much virtualization of all those things. Physical network appliances is what we've been buying, so like checkpoints and riverbeds and F5s and all these things, ASAs, firepower, 9300s, whatever. Physical appliances that deliver one piece of software. What we're creating is virtual network appliances, and they're still appliances because they came from a physical world, so sometimes they have some unique requirements, unlike applications. I told you already that connectivity is network security and telemetry. And then this is my own beef when people use controllers, orchestration. So definitions for me are, a controller is something that provides real-time monitoring and control, incorporating telemetry. So that's like to me, like the original OpenFlow was a real-time flow-based control. Orchestration, which the network service orchestrator, TLF, which we'll talk about, is it's non-real-time, and it's coordinated configuration across multiple systems to deliver an end-user service, right? And then automation is workflow superimposed on orchestration, where you collect the parameters to instantiate that end-user service, and with approvals. So you may collect some parameters. Yes, you can do that. Collect some parameters. Yes, you can do that. So that's automation, right? And I actually did a lot of research on that because I was confused by how people were using those terms. So what are customers asking for foundationally with virtualization? What they don't want is to buy a physical appliance that will only do one thing forever and ever. And this was an example of a banking customer that had 1,400, so large banking customer, 1,400 checkpoint firewalls that were coming end of support. So, they had this perspective for we've got all these firewalls all over the place. Many of them are not fully utilized. We can only use the hardware for being a firewall. So if we're only using 10% of the box for firewalling, the other 90% goes wasted, right? I can't use it for a load balancer. I can't use it for somebody else's firewall. And then if I do fill up the capacity of that box to 100%, I've got to go buy another box, walk into the data center, plug it in, power it up to add more capacity. So that's also something that is not very much agile, right? So that's the concept there. And then OpenStack, I've walked into a lot of customers attempting to do OpenStack for network function virtualization. Who here is in that boat? Anybody attempt OpenStack for NFV? Well, good, don't. So I have customers that spent 18 months trying to, and they're moving to, the topology we'll look at in a second. And then VMware, one is it's controlled by another team. You're paying for a lot of features that aren't appropriate for network virtualization, like SRM, DRS, and fault tolerance. Like you aren't going to run those with network VMs generally. And then what the customers do want to do is, like, if I'm a network guy, I want my own hypervisor. If I'm a security guy, I may want my own hypervisor, or if I share across network security and load balancing, a infrastructure hypervisor. And I want to be agile like the app teams, because the app teams are agile. They spin up an application. They come to the infrastructure teams. They're like, hey, put it in a load balancer. They're like, well, I can't because there's 1,000 other applications on the load balancer, and they won't let me touch it until Sunday morning at 2 a.m. So your application can't be used until I have a change control window to make a change to a firewall and load balancer. So we'll talk about ways to get around that and how we become more agile for that, and really deploy, simplify operations from that perspective, and automate our service delivery. So where is NFV? Everywhere. So anywhere, there's the everywhere. Really, the branch, you can see it at the data center WAN edge, WAN accelerators, routers. You see it inside the server farm, like security within the server farm, accessing the server farm. There's usually pods of management and orchestration, of course, internet egress, and now we have cloud connections. So literally anywhere where you're putting physical network appliances today, there's an opportunity to virtualize, and we'll look at that. So what we're using to virtualize in the data centers and the DMZs and the colos is the CSP 2100, and I'll do a demo because you guys have been nice and quiet for an hour, so you deserve a demo. In just a few minutes, though. I'm going to wait for it. So here's the sort of architecture of the CSP 2100. You've got any kind of virtual appliances running on it. Used to be physical appliances, now virtual appliances. It's KVM based. And then you've got TailF ConfD software. So I'll cover that in a little bit more detail, but that was TailF's first product. The NCS was their name. Network Service Orchestrator is their second product that actually manages their first product. So basically, we've taken Linux KVM OVS and Intel SRIOV, and then put the ConfD shell on top, which I'll show you what it looks like, but turn it into a network appliance. So you guys will get on there. I can't imagine anything that's more at home to me than the CLI of this platform, but not only is it CLI, of course, there's Web UI, there's REST API, and then netconf yang, so it's naturally controlled or orchestrated by TailF NSO. So, and then SRIOV, I didn't mention PCIe pass-through and Intel NICs. So ConfD software, which again is the shell that we put on top of Linux KVM, OVS, SRIOV, and then we have AAA stuff like TACAX and Radius, right? So it exposes only those things of Linux that are intended as a hypervisor, right? So all the other things inside of Linux are hidden, locked down, and eliminated. And so ConfD is actually running on like 100 physical network appliances in the market today. I don't even know them all, but when I log into some of them that I load virtually, I'm like, that looks like ConfD. That looks like ConfD. But really, it got rid of the problem that we had in the industry, Cisco included with iOS, which was, we put something in a CLI. The CLI was the master configuration. And if you wanted to use an SNMP to change a parameter or a REST API, sometimes you'd have to ask us to add that because we had to create all the interfaces into any managed object or configuration parameter. So with ConfD, we have a database, a CDB, configuration database. All the KVM stuff's in there. And essentially, if we put it in the managed object database, it's exposed through all the northbound interfaces, right? It makes innovating much faster, consistency for you much better. So it's just goodness. So here's the software block diagram in more detail for the CSP. And so we have all the interfaces northbound. When you go through the web user interface, which I'll show you in a second, we're basically collecting parameters like that work, like what I call automation. We're collecting the parameters, and then we create the REST API and just go through the REST API interface and create the VM, right? So it's just communicating like that. And then you have various services and things. And NFS client is important here. We'll cover that in a bit. So that's the architecture of the block diagram. Presently, that software is offered on a UCS C220 and a C240 with these options that are on this slide. So you could pick and choose different sizes, disks, memory, CPU, and all that. Generally speaking, for NFV workloads, CPU is the critical component, right? Unless you're doing WAN acceleration or web caching, which are disk intensive, all the other network stuff is CPU intensive. And then here's the 1RU box where you have the various interfaces that you would use externally. And then for network VMs, you have three options for how you would connect the virtual appliances to the external network. You have OVS, Open Virtual Switch, which is not that great for performance. And if you're a network or security guy, the risk of a misconfiguration in the host is pretty high. I'll show you some config stuff, but it's not easy. And then SRIOV is what we're doing. So you can connect a virtual appliance directly to the switch, and we'll cover modes of SRIOV in just a second. And it's a hardware attachment. There's no CPU interrupts, so the performance is the best. You won't beat SRIOV for performance. And then PCIe pass-through is the last option. So SRIOV is many to one NIC, so many virtual appliances to one NIC, and PCIe pass-through is one to one. So here is OVS, and you can connect as many things as you want to OVS. We create the bridge under the cover. So if you spin up a virtual appliance and say, connect to interface 1, and you spin up the next virtual appliance and say, connect to interface 1, you don't have to create the networks. We do that invisibly, right? All you have to do is say you want to connect them all to this interface, and we'll automatically bridge them for you, right? And then the use case for OVS, since it is low performing, but it is convenient, is potentially the management network for the virtual appliances. And then PCI pass-through is a specific use case because it'll pass all traffic regardless of MAC addresses and things like that. So if you wanted to spin up a capture VM, like to Ethereal or any kind of monitoring virtual appliance, and you wanted to span from a Nexus switch to that virtual appliance, you'd use PCIe pass-through, because that'll just pass whatever traffic you throw at it right into the virtual appliance. And guess what? You can run, and you didn't hear it from me, a tetration agent with to Ethereal installed, and it'll capture all your traffic and send it to the cluster. But you didn't hear it from me. So SRIOV is going to be the primary use case for all your data plane connections. And so that's where you can have many to one, and we'll go through some topologies using SRIOV. I'd stolen this because I would never type this. This is just the CLI using KVM to deploy a virtual machine and all the parameters. So when I say we're doing parameter collection for you, that's what we're doing under the covers. You're welcome. So as far as the process of deploying a virtual machine, create the intended topology. So you got to figure out your service chain, right? You got to identify the specific vendors you want in that service chain. You got to review their KVM install guide, so if you have a 100 megabit per second requirement, you go look up, how much RAM, how much CPU, and how much disk do I need for the size that gives me 100 megabits per second, right? And then you download the image, and for the CSP, that could be a QCal2, ISO, OVA, or RAW format. So you have a lot of flexibility in the formats that you can download and consume and load. Then you upload the image to the CSP, and if you want to do it manually, you do it through a web interface. Just upload image. You can SCP push to a CSP, and it'll actually, if you do the web interface, it'll push the file across all the boxes in a cluster. And then you can also just drop it onto an NFS data store, and if all your CSP hosts are connected to that NFS data store, you've just presented it and given it to n number of hypervisors. So then you create the virtual machine in the data plane networks, and then once you spin up the virtual appliance, then you need to connect them together in the switching fabric. So you create the bridge domains in the switching fabric to connect them together. And of course, licensing is not fully automated cross-vendor yet, so you got to license the machines. And then you're ready to go. And you can manually just build everything you're doing today, just virtually. Or you can leverage NSO to create end-user services that'll just pop these things out if you're going to do lots of them, like partners, right? And we'll go through this a little more. So this is just a breakdown of sort of what you're responding to as far as the information you need to spin up a VM from the vendor, just more detail. And also your preferences. So your first choice is SRIOV. If they don't support SRIOV, then it's VirtIO. And if they don't support VirtIO, then it's E1000 or whatever for the NICs, like your order of preference. And then from the CSP standpoint, this is what a VM looks like. And this is just a representation of the configuration database of confd inside the CSP. So here's a web security appliance, and I cut off the UUID because it made it ugly. The UUID would be out there, auto-generated, you don't have to do that. And you can see the disk size, memory, CPU, the file name that we booted from, and somewhere else in the config you'd have NFS if there was an NFS mount. And notice the WSA does not have, it's VirtIO for its first VNIC, second, both VNICs. Because it doesn't support SRIOV yet, we're trying to get them on board with that because the performance will improve. And then the AVI Networks load balancer, which in this case was load balancing the web security appliance, it does support SRIOV, so you see that down on the VNIC 1, right? And I trunked these because you can have as many interfaces on the virtual appliance as you'd like. So here's the long-awaited demo right at the midway point, which was kind of my goal. Let me make this bigger. So can you guys see that okay? Somebody's got to speak. That was just a trick to try to get somebody to talk. So here you have a CSP cluster of 2, small cluster. And so, dashboard configuration, administration, I won't go through all these, but for administration, you can change your, passwords, obviously. The host configuration, well, maybe I'll go into them. So that's real simple interfaces. Host configuration is just, like the basic, like DNS, domain completion, DNS servers, all that kind of stuff. NTP servers, it's pretty straightforward. User configuration, so I can add users. The cluster, so we have 2 boxes in this cluster, you saw that. I could go add more boxes, just hit this plus sign here and add more boxes. The NFS data stores, so this is the marketing box, so they have a whole bunch of NFS data stores, so you can have multiples. And you'll see we use these data stores for the image repository, storing templates that may be reused across the boxes. Like an example would be an ASA, like I don't have it on this box, but ASAV-100 would be a template because I went and I looked up sizing for the ASA at 100 meg, and I created the VM, but I just saved those parameters so I can reuse them every time I want a small, ASAV. So SNMP, so you have like MIB2, host MIB kind of stuff, and AAA config, which this is just this is a beta image. So we just added radius for the upcoming release. We had TACACs from last summer, and then you can have like just general ACLs to control access to the SNMP and the the secure shell and all that kind of stuff. So dashboard's pretty straightforward. Here's the overview. So when you log in, you see total resource consumption. You can zoom into any particular node. Right now I happen to be on node 3, but I could have been on node 1. And then here I have a virtual wireless LAN controller and an AVI controller. And if I go over to the other CSP, I got VSMs and other stuff. So that's the general dashboard. There's a services view, which is all the VMs across the cluster listed with all their network I/O, since we're network people. And then you can also just zoom in and pick any interface. Like I can add monitors. So if I wanted to monitor a particular network interface, I can go in and choose that network interface, and I can plaster a whole bunch of these little trackers all over the place. So then here under configuration, we can configure the SRIOV. So how many people are all familiar with Cisco VICs from a server standpoint? Anybody? Not many. So I mean, we came to market with a VIC, and it was ability to provide virtual NICs to hosts, and so this was another way of doing the same thing, SRIOV. So here you can allocate a number of virtual NICs per physical NIC, and depending on which Intel card it is, of course you don't have to worry about that, because when you hit question mark or fill in these parameters, we'll say, you can allocate 32 on this interface, so your range will be up to 32 virtual NICs on a physical port, right? Typically, we haven't run into any limits. So one card does like 128 shared across all the ports. The other card has per port limits, but you can allocate those here. And then you can also launch a port channel. So if I was using OVS for my management network, I could launch a port channel out to 2 switches, so I have highly available management network, right? And then here are my physical NICs, which I can configure for PCI pass-through, and then the image repository, and you'll see all kinds of image types in here. We've guys do testing. You can see ICE. There's General CentOS. I'll be using this tiny core here, AVI and CSRs and VSMs and our ACS and F5 and all kinds of stuff in here, right? So the first set of images are on the local DAS. So somebody uploaded them directly to the direct attached storage on the CSP. But down here you can see images are also being exposed through the various NFS data stores, right? So let's, I can add an image, but I won't do that now. So if I go over here, you can see there's some things running. So if I want to go add a new image, I'll just do a little, because it's fast. It's a tiny Linux machine that boots in like faster than I can switch screens. So we'll do tiny GUI, because I'll show you a few different ways to provision it. I'm going to put it on host 3. Now this is VNF management. I wasn't aware of this more than 6 months ago. If you want to put down a day 0 IP address configuration on a virtual appliance that's being booted, anybody know how to do that? Because I didn't know. So basically, you create an ISO image, and as that thing boots, you say mount this ISO, and put the configuration for the day 0 config in the ISO, and it puts it down onto the device. So the ASA will do that, the CSR will do that, and if you put the IP address here, we'll create it. We'll create that ISO image, right? So the image name, and we now have the ability to just type the word tiny and it would show up here, but this is an old version. So I got to scroll down through a lot of stuff. Am I missing it? Anybody see tiny core? Higher? See, I got you to talk. That was my trick. What? Lower? Higher? Two. That's one of them. There's this. I usually use that one. Okay. Yeah. So they were revamping the GUI. I used to just type tiny or whatever, CSR. Like CSR would get me all the CSR images. So in the process of revamping the GUI, that went away, but it's back. in a new release. So here's just some general like cores, gigabytes, RAM. I can choose my disk type, IDE or VirtIO. HA service is simply, if I'm spinning this up on CSP3, then I want the pair, because we usually in these environments have to deploy a pair where there's a pair of routers, pair of pair of firewalls, active standby. So all I'm saying is whatever you just configured here, put it on the other box exactly the same size, same everything, right? So it's just a convenience of spinning up things in pairs across two boxes, which are connected to two different top of rack switches. And then, so here's your VNIC config. We go in here, and I'm just going to connect to the outside world with a single interface, but I could add more interfaces here. And I could also store like a firewall image or a firewall template that has 3 interfaces, which is 4 interfaces, which is typical for a firewall. It would be outside, inside, failover link, management link. So, and we'll go through that in a second, because templatizing, good. Just willy-nilly creating stuff, bad. So if I needed to add extra storage, and I've only come across our WAS, requires a separate disk volume for a byte cache. So I would create that here. And then serial ports, which, for the most part, if you're doing a router, you just do 1 serial port. XRV happens to require 4 serial ports. So not a lot of information that you have to enter, right? I mean, I took a long time to talk about all that, but it was pretty straightforward. So I just created, a small Linux service, and over here I can go log into that little Linux machine that just started up. I didn't put a VNC password on. You can actually create ranges of ports for the VNC connections. So for a secure environment, you could, nail down in a firewall only these ports into into the CSP IP addresses. And then there you have, like we're booting through a console here. So if I wanted to go look at what actually happened, we've got the shell. Oops, wrong password. So again, this is conf-d. You can, pipe, do all your normal stuff. But I'll show the whole config right now. So you see the beginning of the configuration. I've got the 2 nodes in the cluster. So when you go add boxes to the cluster, you're really just doing this. The CSP users, which I just have admin on this box, but you can add more users. Each of the network interfaces are here. And so only one on this box has SRIOV configured. This should really not be 0. It should be like 10, 20, or whatever. But that's the number of virtual NICs you're going to present from this interface. And that can be done through the GUI or through CLI. And then the basic CSP config, which I'll just scroll up here. So the basic IP address, MTUs, that sort of stuff. Whether the management network is shared with SIMC or not shared. And then, the version. And notice that what's cool about conf-d is it provides not only configuration data, but it actually also stores the operational data. So how many CPUs am I using and how many are there total, right? We usually don't get that through a CLI, but conf-d allows you to present both operational data and config. So here are all the NFS data stores, right? And we'll talk about that in a second. And then here's the AVI and the one I just created, which was tiny GUI, right? So like a router, if you had like a router BGP or whatever configuration in a router, you can copy and paste a VM, right? So I can go up here and hit, and I want to copy the UID. That's bad, because the U is unique. So just go into config mode, and then service tiny CLI, because that's where we're doing this one from. And then I paste, and then end, and just I have to commit. So now if I go back over to the GUI here, tiny CLI is formed. Same thing, right? I just did it a different way. And then lastly, I've got Postman up and running. If you guys don't use Postman, it's awesome for just doing API stuff. And I don't know how to make Postman bigger. Can I just do this? Yep. So this is exactly what we just did. My Trump joke is it's less than 140 characters, so Trump could provision a VM. So you could tweet a VM. That's the. I didn't actually count it, but I'm pretty sure it's less than 2 rows, right? So anyway, the tiny REST versus the other things, and it's going right to the API. It's a post, so it's a create kind of action, and I've got my authorization in here. You guys can see my password. I didn't create it, and then that's the actual send. So created, right? And now if I go over here, you'll get a tiny REST pop up. So 3 different ways. Now there's a 4th way, which is to actually use netconf yang through NSO, and we'll look at that a little bit more in a second. So any sort of questions, like I can also go into here and say show services, and I can see, in a structured way, all the services are running on a box, and there's a bunch of other sort of show commands. Is it good? So it's a network appliance hypervisor focused on SRIOV, high performance network connectivity with hardware segmentation. So back to our regularly scheduled program. So let's look at some topologies that we can build out virtually. So this is, if we can do this with the CSP, we can build networks inside. Generally, we're not, because OVS isn't that performant. So we could do this, come in, like say from a PNIC, go over to outside interface of a firewall, and then inside of the host, go through OVS. And I didn't show you that configuration, but you can do this. And then hit the outside of the load balancer and then come out, right? That would be a simple service chain in a single box. And then I'd have 2 of them active standby, right? Think of it, do you guys remember the Catalyst, well, I remember Catalyst 6500 service chassis, right? So we would take, when 7K came out, we'd throw a services chassis, and you'd have like a firewall services module, an ACE, may it rest in peace, and an AM, right? So those 3 services, now you just have a compute box, right? You just have generic compute. You create virtual appliances, or virtual blades, you can call them, rather than creating physical blades in a switch chassis. So this isn't that performant. It'll work. So another way to do it is with SRIOV. Again, just active standby boxes. We're still thinking physically, so we're going to move away from that in a second. So active standby boxes, and so you're coming into your switch. You've got these service chains, just bigger service chain this time. So you come in, and notice this is virtual Ethernet bridging mode of SRIOV. This is the default mode for the CSP 2100. So if you send 2 services, in this case the firewall and a load balancer, to VLAN 12, and this is all one NIC, so don't be confused. I'm just like, this is, I call it the God box model, but I don't like to get religious. So people have thought of God boxes. I want to just send something into a box, and it's going to like crack open SSL, do a million things, and then re-encrypt it and do all this crazy stuff. This is kind of doing that with a bunch of virtual machines, in a single box, right? So so you're coming in to the outside of the switch. You're coming into the box on one physical network interface, and then literally you're coming in and you're bouncing back and forth between the virtual appliance and the Intel NIC being bridged in hardware, right? So the traffic never sees the switch after it enters that first virtual appliance. And because the firewall is on VLAN 12 and the load balancer is on VLAN 12, it's bridged in the NIC on the same hardware bridge. Got it? So that's one approach. And some customers are like, this is awesome. I never have to leave the box. I just stay in the box. I'm in hardware, and I just right through the chain, right? However, there's the other customer. You can never satisfy all the customers with one thing. So the other customer is, I want to see all traffic in my switch, so I have one point of telemetry and control for all traffic. So in that case, we do VEPA mode, which is now going to be released in our Nexus 9Ks, ACI mode first, then standalone mode over the next several months, because it actually needs to coordinate, the SRIOV needs to coordinate with the switch. So if you're a switch, if we go into VEPA mode on the CSP 2100 today, and we send the traffic to the switch on VLAN 12, let's use that one as an example, and the switch is going to get a packet in on that interface on VLAN 12, and then the destination MAC address is going to be out the same interface on the same VLAN. The switch is like, why did you send this to me to begin with? And drop it. So with a VEPA support, the switch will accept it, understand that there's multiple other things off of that network interface, and send it back. And hence the animation right there, which is you see it go to the switch and come back, go to the switch and come back, go to the switch and come back, right? So in this case, I'm going in and out of the whole thing. And of course, you know, we're still doing, I didn't show the cluster links, so the firewall has a cluster link. It just gets too busy, right? And all on the same NIC, like it doesn't have to be a different NIC, but the cluster links, as required, are also crossing between the two boxes, right? So the other thing you can do with SRIOV is I've got all these virtual network functions or virtual appliances plugged into the CSP, and they're all sharing one interface from their virtual functions to the physical function, the port. And so this is one topology, but we're working through a couple of things with the Intel drivers. But this is possible with one of the NICs, not both today. And so you can do 2 ports out of the CSP, like 10 gig, up to a pair of top-of-rack switches that are running a virtual port channel, and then have n number of VNFs share those 2 links. Right, so you're getting switch high availability on just two interfaces out of the CSP for all the VNFs, if you know that's something you require or desire. And then when it gets to virtualization in general, a lot of people are concerned about performance. How many people would be concerned about performance, just to make you guys do something? Okay. Because you don't want to be on the hook for something that isn't performing. So one thing we do conservatively on a CSP is we hard allocate resources. So you got 15 cores, if you got 44 cores, whatever the number of cores is, if you added 2 vCPU service, we subtract 2 vCPUs. Like, you cannot oversubscribe. So we're right now being very conservative about running services on there. When we do run little teeny tiny services, which just gets to scale up, scale out, and scale down, is, you know, we've got a lot of different tests. This happens to be a test with Avi Networks load balancers. We've tested with Radware and some others, which some pretty, you know, great performance. But let me just build this out. So I can take from a single core Avi, and I was surprised by this, that's why I included it here. For a single core, I can do a gigabit per second and 2.5 thousand transaction setups per second with large keys on an Avi network, on a CSP. So directionally, and we'll talk about this later, customers are moving towards teeny tiny load balancers per application. This is how we become agile. We build virtualized infrastructure that is dedicated to a partner, dedicated to an application, dedicated to a cloud VPC, right? So we'll go through those models, but that is an option. Initially, what most people think when they start virtualizing is, I've got a 10 gig firewall physical. I'm going to go create a 10 gig firewall virtual. But we're going to talk about reasons why you can do that. And we have a new ASA v50 coming out to do 10 gig. But there's a lot of value in shrinking the firewalls and scaling down and dedicating firewalls to a particular purpose and reducing the impact domain of changes to that firewall, right? So we'll go through that. So the Avi network's a good example. Down to 1 core at 1 gig. I can do this 4 core, 10,000 setups. So it's basically a gig per core. And then the way we load balance multiple, so even on a single box, 40 cores. And then what we're doing with one customer is to even scale beyond, like a single 40 core on a single CSP is doing multiple Avis. And a load balancer, I'll talk about this a little bit, If you want to scale them, you do ECMP, equal cost multi-path. So you're essentially load balancing the routes into the load balancer, and then hence scaling the load balancers out. So this hub that we've talked about kind of nebulously is a switched fabric. Usually it's hardware at the edges. It's hardware in the middle, switching. The edges are ASRs that may sit on MPLS clouds, may sit on 10, 40 gig direct connects, may sit on the internet connections. So all the outside is virtual or hardware, the inside is hardware, and everything else is virtual as to the greatest extent possible. So I call it the virtualization sandwich because it's hardware, virtualization, hardware, right? And so we scale up at the core and the edges, scale out in the middle. We have hardware segmentation for security throughout because we're using SRIOV for data plane. It's a centralized place for logging and telemetry, net flow, packet collection between all interactions in the business. There are ways of automating ACLs in this hub, which I'll talk about later, which we're working towards. Not available today, but the concept I'll share. And there's also very easy to start adding service catalogs on to add partners, remove partners, add clouds, remove clouds, add, what else do we add? Apps, and remove apps. So notice here that in the data center or in the extranets, I'm showing lots of little things. So that's the concept we'll look at later, which is dedicated virtual appliances per partner, per app kind of concept. So now we're going to start building, and what are the sort of best practices there. So first, high-level plan, like we just talked about. You need to decide: am I going to recreate my physical, big physical firewall? One customer has one firewall for 400 partners, so 4 gigabits per second, because no partner is more than 10 megabits per second each. In order for them to make a firewall rule change for any partner to either add an application or remove an application, they have to wait for a change control window because it affects 399 other partners. So in that model, I can go to a little tiny virtual firewall per partner, and I deploy, with orchestration of course, 400 little 10 meg firewalls, right? That's an option. Or I take groups of partners and I break it up into smaller firewall domains. So you have to decide, am I going to go big shared, in which case you are going to save space, probably save power in a colo facility because you're virtualizing. You're going to have the ability to virtually connect anything, so you don't have to walk into a colo facility to plug something in, but you're going big physical to big virtual. Or you go big physical to tiny dedicated virtual. And then as far as the CSP is concerned, these are just best practices, and we ship it this way, but the direct attached storage, RAID 10 for performance, and high availability, and we do offer encrypted drives, we've asked for that. And then NAS, so use NAS because there's high availability benefits from using NAS, also convenience from having a single image repository. So when you go to start connecting the CSPs to the switch fabric, again, repetition is good, patterns are good. So here you've got the CSP. Was there a question there? Or are you stretching? Oh, I got all hopeful. So you got your management network. The CSP IP address, you could share it with the SIMC, so that's M1, right? And that's also where you would put your NFS because the NFS client comes out of the CSP management IP. So then M2, you separate for your virtual appliance management interfaces. So every virtual appliance you spin up has an interface that you attach to M2 so that you can manage. NSO is also going to be on M2. So NSO is sitting on M1 to spin up the virtual appliances through the CSP IP address. I have other diagrams with that. And then NSO is sitting on the virtual appliance management so that it can configure the routers and the firewalls and the load balancers if you're using that, or whatever management tool you use. Right, so then D1, D2 is only if you're going to do port channeling from the VNFs. So you'll do D1, D2, and all virtual appliances that do port channel can share those two. You don't have to keep adding more and more ports. And then lastly, D3 would be for single attached virtual appliances, like ASA doesn't do port channels, so I would single attach it on that, just so I don't have orphan ports on the top of rack switch. So does this make sense? Any questions? So this is like, I'm just going to pop out these boxes onto the switches with this connectivity model. And yours may vary. It doesn't have to be this way. This is just a common approach. So then I've got my fabric, and I'm not showing all the connections here, but I'm just starting to spin up these. These are the white boxes onto the either Nexus ACI or standalone switches. I've got NFS going. I got my separate VM management network up there. I mentioned NSO, so you see now the NFS and the NSO sitting on a side. So NFS is attached to all the CSP IP addresses, as well as the NSO, because it's got to spin up the virtual appliances. And then NSO is also potentially configuring the virtual, the leafs. We'll talk about virtual wires in a second, how we connect and service chain these appliances together. And then the virtual port channel as appropriate. Now, I threw in this stuff over on the right side here. These are all the ways that we have in the Nexus switches to provide scaling for virtual appliances, or any appliance for that matter. So I mentioned for AVI that load balancing we scale with ECMP, equal cost multipath. So we kind of multipath route into a bunch of load balancers. That's how we scale them. Intelligent Traffic Director is an infrastructure load balancer built into Nexus standalone that allows me to horizontally scale firewalls. They could be virtual firewalls also running on SRIOV. So I can have an N+1 firewall arrangement with ITD. Then we have Smart Channel, which is a load balancing mechanism for bump and wire services. That would be like an IPS. So if I had a 1 gig IPS and I needed 5 gigabits of IPS, I could load balance 6 of them, one for failover. And it's bump and wire. It's a source desk this way, desk source this way, so all the flows remain symmetric, just like ITD does the same thing to keep flows symmetric across a cluster. And then if it's a capture type of virtual appliance, and I'm doing the span over a PCIe pass-through, then Nexus Data Broker allows me to scale the number of capture appliances. And then lastly, we have a couple new features that came out that I was going to throw in, but I'm probably not going to have time anyway. So these are additional capabilities we've been adding. One's called Katina, and it's intra-switch service chaining and clustering. So it's ITD on steroids. Both of these are kind of like enhancements to ITD, where I can have service 1, service 2, and then scale out each service and chain them in Nexus. And then pervasive load balancing is doing that across a fabric, not within a single box. And we can get you more information on those features if that's of interest. But basically, we're creating a service stitching fabric, and imagine all your virtual appliances are potentially scattered all over the place, chained, multi-tenant, SRIOV hardware attached, and we'll build to that. So here is for the virtual appliances, I started spinning these things up, and they're like, wait a minute, there's a pattern here. Again, it's 3. The number shall be 3 for the patterns. So the first one is 1 data plane, 1 management. So that could be it could be a host, it could be a capture VM, but it's a 1 interface, 1 data plane, 1 management network device. And then you have a go through stateless, which would be like a router, because if you had 2 routers, there'd be outside for a router in a service chain and inside for a router, and in a management, there's no failover or cluster link. And then the last one is the firewall type or the load balancer type, which is outside, inside, failover link, and then management, so 4, right? So there's 3 different patterns for spinning up virtual appliances. And then you have to know if it's port channel or not. So we can literally make wires and throw appliances all over the place, which I'll talk about in a second. But some of the customers take baby steps, and they're still thinking virtually. So it's kind of like a hybrid physical virtual approach. So for this, what this customer was saying was, the way we do our extranets today is we have a physical pod we build, and we put up to 60 partners on that pod. And when we hit the 61st partner, we start a new pod, because our impact domain can't be more than 60 partners on a failure, right? So so how do we create that virtually? So we create CSP pods, take a pair of CSPs, build them out to support 60 partners, and then when they hit the 60th partner, we drop in another pair of CSPs to support another 60 partners and another and another. So that's this kind of approach here, which is just sort of recreating the same approach, hardware segmented pairs, incrementally growing as I grow the service. So another approach, and this can be automated, or you can do this manually, is I have a whole bunch of CSPs stacked on top of rack switches, and I'm going to deploy a new service. So what is the thought process I go through? Well, and all this is available through APIs and things. So I go through the thought process of I want to put it where there's at least enough resources available, but ideally where there's the most resources available. So I'm essentially load balancing the placement of the virtual appliance to the place where it has the most resources available. So if I just added a new box to the grouping or cluster, it may have the most resources available not only for the primary service, but also the backup service because it was empty, right? So in that case, we have to exclude that we have the primary service going to a CSP, but we want to exclude that CSP for the backup service. So we don't put the backup on the same box. And then also through the API, you can get LLDP information. So we can also say logically, don't put the backup service on the same top of rack switch, right? So you can just query the CSPs, is this one, may have the most resources available, but maybe it's plugged into the same top of rack switch. Don't put it on that one, right? So it's affinity, anti-affinity logic, but it's pretty simple and straightforward. And so, for the customer that's doing box for box, they'd end up doing that. But for the customer that's literally just load balancing the assignment of virtual appliances wherever the most resources are available compute-wise, it could end up all over the place. Now, you're spinning up the virtual appliances, they're not actually connected together yet, right? So now we have to create the bridge domains, just like service chaining in the old-fashioned days. We've got to create the bridge domains between these services. So they're bridge domains, there's three patterns too. And again, if you're automating this stuff, there's three patterns, or orchestrating, better word, which we are working to do this with NSO. But your three virtual wire patterns would be, I have two CSPs or two services that I want to chain together, like that firewall load balancer several slides ago, many slides ago, in the same box, right? In which case, I'm really just doing the SRIOV, VEB bridging potentially within a NIC. So there's that way of virtual wire. Then there's a virtual wire that I would create between two services that are on two CSPs, but on the same switch. So I'm going to come out those CSPs, up to the top of rack switch, and the virtual wire is just, bridging between two interfaces on the same switch, which again would be parameters that would be passed through NSO. And then you have the last one, which is two virtual appliances on two different CSPs on two different top of rack switches, in which case it's a VXLAN fabric. I need to create a VXLAN extension between those 2 points, right? So any sort of questions on that? Because now we get into the orchestration and automation to wrap up. So I've just given you the patterns. Now it's like, how do I not have to build that myself, right? Nothing? I'll be up here for questions after. Don't leave me hanging. Okay. With no OVS? So, I mean, we get statistics from the NIC card for VEB switched SRIOV. We actually have to expose them now because of that exact question. We're exposing because we were exposing the stuff through the NIC, but when we do SRIOV, we have to get the information from a different place on the NIC. So, but we do have access to it. Yeah. Yeah. So we have two virtualization, and it's a good word, families. So the branch office has NFVIS, and our data center cloud group had pursued CSP. CSP allows you to get started more easily with manual management, the CLI, the ability to copy VMs, and actually what I didn't mention was the ability to copy and paste a complete configuration of VMs. So if I have a box failure, and it was on a slide, but I forgot to mention it, I could get a new box from TAC, put it in, paste the config on the CSP, and all the services come up. So the CSP was really targeted at HA, active standby services, and we do have a service health check restart function. And then the branch approach was, hey, I need a controller, which we added our Elastic Services Controller concept out in the branch, because that's an island, and if the WAN goes down, I need autonomous control out in that branch. So we've got two Linux KVM-based solutions that are fairly similar. Both use confd. One was intended for manual GUI management and cluster management and CLI management, or an NSO, and the other one was also for NSO. So we are merging those. So that's part of the reason I brought Gunnar. So over time, we're going to take that branch NFVIS software and the CSP software we're talking about today, and what you'll get is the cluster GUI and CLI that you saw here today with the robust API they use for orchestrating the branch services. So, and if you have any more detailed questions about that, just come see me after. So be careful when I ask for questions, I'll get really hard ones like that. So orchestration, really, I've taken the NSO training classes. I highly recommend them because it gives you a different perspective. It almost reminded me of the movie Sixth Sense, because when the kid figured out, he sees the dead people. When you go to NSO training, you're almost trained to recognize patterns, right? So I was I see all these patterns that I didn't see before. So here you have NSO. It was the second product from TLF. And what's ironic is confd is in TLF too. So the shell of NSO, Network Service Orchestrator, is that same software you just saw on a CSP, except in this case, the configuration database, which is a single device on the CSP, is a multi-tenant, multi-device configuration database, okay? So it's just like the same database, but for multiple devices, multiple tenants, right? So it's a bigger database. So then you have all the same interfaces northbound that we already talked about. There's a service management layer, which is the sort of service models or templates I'm going to create for an end user service. And an end user service may be able to configure firewalls, load balancers, switches, spin up virtual appliances, do all the stuff you guys are doing today. And then in order to talk to all those devices, we have these things called network element drivers. And so, we build them, we maintain them, you consume them. And pretty much any device. We even have NEDs now in proof of concept to configure into Amazon. We have NEDs to configure into the Meraki cloud because they added provisioning APIs. We're starting to work on NEDs that will go into Tetration APIs because they're adding provisioning APIs. So literally anything that's got an API, CLI, we can create a NED for, and it's like a chicken and egg problem. We have a NED which probably addresses most of the features of any vendor's product. If you actually had an end user service that you wanted to create that used a feature that wasn't available in a NED, we commit to around a 4-week turnaround to add whatever that feature is to the NED, right? So, and if we don't have a NED, which is an example of Avi Networks, which I showed in an earlier slide, we also build those NEDs in 4 weeks. You have to give us the config you're going to use and access to whatever it is you want to manage, and then we give you the NED. Right? So it's a pretty straightforward process. And all the NED does is takes whatever the interface is southbound and converts it to Yang to consume through NSO. And I kind of covered all these things. There's a bunch of different management layers, but I think we're running out of time, so I'll skip through them. So package manager, if you're going to create an end user service, we actually call that a function pack. A function pack is a combination of the service models plus the NEDs bundled together for an end user service. And then notification drivers, so like when we implement configuration to a device, notification that it's done. And then this is a hierarchy of the Yang modeling within the CSP, just as an example. So you have a cluster, which is then comprised of resources, which is comprised of a service, which has physical network connections. This is just some example Yang that the CSP generates. And the takeaway I want for you here is that I think it's cool, because I think in order to do network management, we can't have this approach of even NEDs and a constant where the devices we're managing are always changing. So how do we keep up with all the new capabilities or change capabilities of devices? Well, that's what Yang was for. So every time we compile the CSP image or the NFVIS image for the branch or anybody that's using confd, all the managed objects in the database of that device are updated in the Yang so that you just load this Yang file into NSO, and now you have access to those new capabilities. So we added SRIOV to CSP last summer, and the new Yang files were immediately consumable by NSO, and then I can configure all the SRIOV parameters through NSO, right? So as we add radius, as we add TACACS, all that is published to NSO to consume. And I just highlighted some here. So when we go to create an end user service, this would be an example of let's build an extranet connection with NSO. So service catalog wise, and I'm doing this with a lot of customers now, you got to break down the one with the 400 connections. That's like they say, and they agree, they have 400 snowflake connections. They're all different. They've all been built over time manually, and they want to get to a standard set of connections. So minimally, you've got IPVPN, MPLS, or dedicated line, and I own my side, or both sides, or neither side, in which case I don't have to worry about it. But so this is, I'm going to create a service catalog with at least 6 combinations if I have all of those. And then I want to do parameter collection. So it may be like, what's the name of the company? What's their address in case I have to ship them a box? If I'm not shipping them a box, what hardware do they have? Juniper router, Junos version. All this information is relevant. What's their peer IP addresses? So you collect that in a form, drop it into a database, and NSO grabs that information, and then we build the service. So with NSO, the virtual wire service, and this could be a fabric or a single box, will lay down through the NED to Nexus, will lay down a few virtual wires, right? And actually, I'm doing this in the opposite way, because usually I spin up the virtual appliance and then I do the wires, but we'll do it the other way. So then I need to spin up a VM and give it a day 0 IP address and attach it to those wires. So I do that through the NED for the CSP, which really is just it talking Yang to the CSP. And then I need to lay down the basic IP addresses of the CSR and the ASA. So that's when I go to the IPAM. So NSO has VLAN resource management for the domain it controls. So it can do VLAN, take a VLAN out, don't use that VLAN again, and provide that. For IPAM, there's all kinds of other systems doing IP address requests. So you tell NSO, go to info blocks, go to QIP, go to whoever. And then you do your VPN configuration, which we're going to be building standardized templates, which may be sufficient for your environment, or you may have custom. If you have custom, you just need to build this once. You build a master config, and NSO will spit out an XML representation of that config, and you just need to go in and identify the variables that will change each time you deploy that service, right? So, interface designation, the description of the interface, the IP address of the interface, all that, the host name, all those things. And then after that, NSO can be used to manage access lists. So once you're done with the all the way up to the VPN or the connectivity layer, network layer, is over time, the frequent changes will be access list changes. And we'll talk about automating that in a second. So really what we just did was we got a VLAN from a resource pool, we got the management IP address, did a day 0 config on a boot up, and you guys can read through this. I think we're running out of time. But those are all the steps involved in provisioning that service. And a lot of us, how many people do scripting to do this kind of stuff? Yeah. So scripting is very common. It's very fragile. So NSO allows you to say, if I'm going through and there's like 12 steps, just random number, 12 steps in this program. So you go through and you're like, I'm going to provision this service. If I fail at step 10, NSO will automatically undo those things. Or you manually, it'll show you what it's going to undo. So it has the intelligence to be able to roll back on a failed end user service deployment. It also allows you to do auditing because in that database that I described, you basically have all the parameters of all the devices in that CDB. So every device and every parameter is in this one place. You have a common API to set a parameter on a Palo Alto Networks firewall, common parameter to set that same parameter on a ASA firewall, right? So you have this one point of control, common interface, common API to access all the configuration parameters of all the devices in the end user service. And then inside that, so in this one database, and then inside that database, there's the intended configuration, but you can also go sync because somebody made a change to the local device, so you have the actual configuration. So you have intended and you have actual, and you can get config diffs and audits, and you can also push the intended configuration to fix what somebody did locally, right? Or you can take what somebody did locally and turn it into the intended config. So does that make sense? Like you got all kinds of control over the status of the configurations. So when you took the configurations, your master configuration, and you exported the config in NSO, it asks you, what do you want to create a variable for? So address would be one. So if I type in IPv4 address and I make it a variable, it shows up in the NSO GUI as a parameter that needs to be collected, right? Now you could go get it from info blocks, but otherwise it just automatically shows up as something the administrator needs to type in, and we enforce the format to be IPv4 because that's how we variable typed it in the parameter, right? So what we end up with is the hub, which has a bunch of virtual service chains. Now, they're big honking virtual service chains if you're doing big virtual appliances, just like you do today with physical. These are the ones that are fairly static. I wouldn't use orchestration for these because the internet egress with the content filtering, if you're using that, is not going to change very often. If you have, a load balancer and a pair of web security appliances or blue coats running in this environment, it'll be very rare that you're going to spin up a third blue coat or a third WSA, right? So just do that manual. It's not changing that often. Same thing with the remote access VPN. You're managing user-based policies on the virtual, VPN gateway, but really, the actual infrastructure is not changing that often. But when it comes to partners, you have the choice of doing, a big shared virtual infrastructure for many partners, or a virtual infrastructure per partner, which we'll get into in a second. So these, even e-commerce, you may have a lot of change on the e-commerce side, so that's something you want to automate. And then, of course, VPCs into clouds, or VPNs into clouds, are something that you'll have app dev teams come to you and say, I want a virtual private cloud to do app development for 6 months, and then it goes away, and another group wants to do app development and it goes away. So that is another thing that will change often, and hence worth investing in orchestration. So now we've got this hub, and we've got service chains coming from all these different semi-trusted or trusted parties, or untrusted. How would I implement security automation? So we've talked about security group tags at Cisco, where we put a tag in a data plane and carry that across the network in order to create trust, because access lists are so hard. So the other approach would be, let's manage access lists. So in this case, think of this workflow, and again, this is something we're working towards, or we can do with AAS. But as I engage with a partner connection for a customer, go into the environment and take all the destination IPs and ports and create a master list of all the applications that you publish to the partners, right? Because that's essentially it. So you have the app name, the domain name, and maybe various IPs and ports. And then you have your partners, which you assign IP addresses to, so that you know what the IP addresses are of your partners. So you have a list of source IPs that are for partners and remote access VPNs and internal employees. You have a list of applications. Now, in this set of tables, I just need to start grouping things. So if I had an application that I want to expose to law firms, I just tag it with metadata that says it's a law firm application. And then I might have 10 partner connections that are law firms. So I tag them with the same metadata, and just because I have law firm here, I take the two sets of IP addresses and I lay them down on the firewalls for that partner. And if somebody removes a label from the app, all the law firms lose the access list for that app. Now that would be scary today with a big shared firewall, but here we're talking about a firewall per partner, so changes can be made in the middle of the day. So all of this is a journey, hence the name of this slide. And so there's a lot of value. It's like it's 2005 or 2003, app virtualization, right? We are on the cusp of a journey, and we've seen it play out, and we're going to do it faster than the application folks did, right? Because we've seen it played out before. So the value is huge. So as far as new network topologies and approaches, we have optimized traffic engineering, path selection, path acceleration in this hub, because everything, it's like Memphis, the FedEx, everything's one hop from Memphis, rather than backhauling to my data center and then going over a VPC to the cloud. So enhanced telemetry and analytics. The group-based policy is something to move forward towards as we organize. Your security services are independent of the clouds. So this was a customer taught me this, which was, hey, I want to use FireEye. I'm like, okay, but it's not available in all the clouds. Well, okay, we'll add it to the service chain for the connections to the clouds in the Secure Agile Exchange hub. So there's also value in saying, and their perspective was also, I want to do Palo Alto network security, but if I do it in the cloud, I'm paying for a super large instance that's always on and a big Palo Alto license in that cloud. But if I just bring it across the wire into the Secure Agile Exchange hub, that always on instance is free. I still have to pay the license. So it's important to consider which side of the wire, the direct connect or whatever you put a service on. And so anything that's large and always on, bring it into the hub. Everything that's transient and small, push it to the cloud, from a cost standpoint. And then you do have the option of a whitelist security model if we got into the details with that other thing. With the hub model, you have fewer circuits, often cheaper circuits. I touched on that. It's carrier and cloud neutral, so if you want to shut down operations in a particular cloud, you're not tearing down connections because they're persistent through the carrier neutral facility. Lower infrastructure costs. You pay about $3,000 per rack in a carrier neutral facility. So if you go with virtualization, you're taking up less space, and you don't have to pay for the smart hands to run cables, which could be, from my British customer, 500 pounds to run a cable, right? Because you're doing virtual cables, right? So consume only what you need, completely shared resources, scale out rather than up. Lights out, don't have to walk in, and a branch equivalent would be don't have to drive a truck to a branch. Well, in this case, I don't need to pay for smart hands. Another customer pointed out this is really helpful for mergers, acquisitions, and divestitures, because when you bring on a new company that you acquired, it is like a partner, and then you relax security over time, and then when you want to remove them, you cut them off like like an arm. So like literally you can add and remove mergers, acquisitions, and divestitures, just like partners. So simplified, operations, no Linux, Literally, we're getting virtualization with the same operational model as a physical world, because SRIOV is taking those virtual appliances and hardwiring them to your switches. From the switch, it looks like a physical appliance. And as you can see from the virtual appliance, it looks like a physical appliance. You don't have any overlay networking you're messing with other than the top-of-rack switch overlay network, which is just virtual wires. So improved configuration accuracy and auditing, telemetry and analytics, lots of options because you have this hub and control point. Agility, again, adding service catalogs for things that change often through orchestration and automation. And the ability to turn over new technologies, change firewall vendors, migrate between vendors, have mixed vendors, because you have a normalized way of deploying all these different infrastructure appliances. Remember, all infrastructure appliances look like 3 different things to a CSP, right? So we're, the journey is here. I love psychology, so Maslow's triangle. We have kicked butt on connectivity, performance, scaling, and availability, but we have not, there's a long journey ahead. Virtualization is the start. Governance is creating the patterns. That's when we can get really sharing and efficiency of the infrastructure, and this is sort of, orchestrating the path. Ultimately, this is what Cisco is doing, kind of not messaging it properly, but we have the infrastructure below, the virtualization infrastructure, including third parties as an ecosystem. And then if you were to build your own single pane of glass, what would that look like? Well, it would be, the old Microsoft, what do you want to do today? And it's, do I want to deploy, operate, or retire a branch, a partner, a cloud VPC, or an application? And then from that first set of questions, you can go to the new service catalog we're working on here, which is deploying virtual private cloud, connection to the virtual private cloud, deploying a partner, deploying the e-commerce app we're also working on as part of this. And then, for your branch, you go to enterprise service automation. For applications, you'd have a decision tree of, is it private, public, or hybrid, Cloud Center? Is it public SaaS, Cloud Lock, right? So that's putting a big single pane of glass on sort of all the things we do, which in the agenda I said IT as a service, because really what we're doing is saying, we're going to give you a service catalog for all these